different, what do we want to call those
parameters?
Parameters in our function.
Yeah.
Y equals a sine b, x minus c plus d. So what is the first thing that you like to do when you do these?
When I do this, the first thing that I like to do is I like to just identify the principal axis.
Principal axis is the axis that goes through the middle of the whole waveform, right?
Exactly. Okay, and now, well, why don't we find one letter at a time?
Right.
Okay, so you remember that A is the amplitude. Okay, Ms. Borb.
Amplitude is measured from the principal axis if you want to. We can just measure that distance right there. What does that look like?
Well, this is -1, and the principal axis is between this. So the principal axis is at -3. So it looks like, and this is going down to -5.
Right.
So
2?
Yep, it looks like it's 2. Now, if you want the formula, I always like to just have little handy things that work always. You can always do max minus min over 2. So -1 minus -5. So just find that basically what you're doing is you're just doing the distance and halving it. It's the same as...
Right. Same as doing that. Okay, so A. What do you want to do next? Let's find B.
Always. I always like to go left to right.
Left to right. So B, again, has to do with the period. And we find that as... using the formula? You want to use the formula?
Yeah, I do.
Okay.
Remember that it's the number of cycles in 360. So if you don't have that written down in your notes yet, make sure that you do, yeah? So B is always
360 divided by the period.
Right.
So in order to do this, we have to know what's the period. We can get that right from looking at the graph, and the period is 1 full cycle. There we go.
Right, period is one.
Period is 1 full cycle. So right there, we know between 0 and 180, it repeats. And then it goes again. So 360 divided by our period, which is 180, gives you 2. Which
Also
makes
2.
sense, right?
Yeah.
Because if you look at it, the number of times it repeats between 0 and 360 is 2. And that's what B gives us.
Exactly. Number of cycles in 360 degrees. Great. Okay.
Now let's look for C.
C. Okay. So now, just to quickly note, right now we're working with the sine function. Then we'll see what happens with the cosine, okay? So with the sine function, we know that the sine always starts, well, starts at 0, 0, right? So it starts in the middle of it. So it doesn't start the max or the min. So it's right there. So this is good. The shape is...
that's good. It's not shifted, right?
Yeah, it's not shifted at all. So we don't have a D. Cool. Let's do the last one.
Let's do D. Now that's our vertical shift, up or down, right?
Up or down, vertical shift, exactly.
Outside of the function, sine x, and so we know that that's going to shift up or down. And what does it do?
Well, your normal sine curve has a principal axis of the actual x-axis.
Right.
So you can just see how much your principal axis has been shifted down. And we can see that in this case, it's gone 3 down. So that means that the whole thing was shifted
-3.
-3.
And what do we have? We have everything. Voila, we can write our sine function. Y is equal to 2 sine 2x.
Oh, yeah, I didn't have a C.
No C, -3.
Okay, Ms. Borb. Now they're also telling me to write it here as a cosine. All right. Now look, if you go through the A and the B and the D, they stay the same.
Right.
So the only thing that's going to change on us, and I'm going to make this green again, so this is for the cosine, is the C, right?
Right. We're going to shift it.
And you better know your cosine and sine, right? We know the cosine starts at but at 0, it's at the maximum. So right here. So this could be a shift, right?
Right.
Or if you want to, you could start it here, but let's just go easier. So that means that this should be here, but instead it's been shifted 45 to the right.
So now to the right, does that give us plus or minus?
Well, this is a minus. So remember that when you put it into the equation, you have to switch the sign.
Right.
So still 2, still 2. So this is going to be minus
45 degrees, -3.
And there you go. And you can graph it on your GDC, set the window, and see that it graphs it the same.
Good.
One more?
One more. Let's go. Okay, write the equations again. We're going to be doing the same thing. First thing we did was principal axis.
Oh, yes. Naughty, naughty.
Draw your line. This one looks a little bit more difficult. Max min looks better to do on this one, right?
Yeah, so this is 1 and this is -5. So there's 6 units apart, right? So I can kind of, I don't know.
We know that that's going to be y is equal to -3, right?
-3 because it's the halfway. Yeah,
right.
so this is okay.
So we found A, now let's find, we found our principal axis, now let's find our amplitude from there.
And you suggested using the formula.
Yeah.
I like that.
Max minus min, my max is going to be 1, minus a -5 gives me 6, over 2, 3.
And again, you can see that the distance from, oh. Stupid. The halfway point between 1 and -5 is -2.
-2.
Oh, Ms. Borb, what are we doing? Okay, so that you can see that makes sense. So this is 3 units and this is 3 units. So your amplitude is 3. Okay, let's keep going. Remember, B is always, and I'm going to write it this time.
Good thing you caught that. You would have had to pay.
Number of cycles.
Number of cycles in
360. Okay, so look, here, one cycle, 90 degrees, 2 180. So how many are we fitting in 360?
4.
4. Now, before I put 4, I do like that formula as well. Remember, the formula is always 360 divided by the period. The period is how long one turn is, right? Boom,
yep,
90. So this is why it's 4.
So now we found, what have we found? A, B, what's next?
We found A, B. Now we're going to go to C, that pesky C, and right now we're dealing with the sine. Okay. So sine. So we're going to have the C. Good. Well, this is a little bit trickier, right? Because remember, the sine curve is in the middle, right? Between the max and the min. So that means that it's somewhere here, right?
Right.
And this is tricky. But that's okay. So look, if this, I know this is at 0, this is at 90, I know that just by symmetry that this right here is 45.
45,
okay,
yeah.
Right? So max is at 45, min, and you know that that midpoint is always halfway, right? So I suppose it should be on the principal axis. So
halfway between 45 and 0 is 22.5, right? So what we can say is that it's been shifted 22.5 if we're using the sine function.
The sine function. Should we do the cosine right away?
Sure.
Okay. So take a look at the
Or do we want to flip it?
Yeah. You know what? Let's do the cosine after. Let's quickly do the D. And remember, the D is just the shift off the principal axis.
Good thing we have that at a corrected -2. So one possible equation would be y is equal to, what do we have there? 2?
3.
What do we have? 3? Oh yeah, 3. Sine 4x minus 22.5 minus 2.
2. Okay. Yeah. Okay. Now here's the tricky part. Now I'm going to do the same thing with the cosine, okay? Now the amplitude is still the same, and the B is still 4, and the D, the up and down, is the same, so that's still -2. Here's the tricky part in this case is, if you're doing your cosine, you could be here, or you could be here, but look at how nice this is. This has just been flipped, so you know what we can do? Let's cheat a little bit. I'm going to make this 0, except it's the wrong way around. How do I adjust that?
With our A, right?
Ooh.
That flips us.
Right, when there's a negative in front, that means it has been flipped.
Yeah.
Do I have to do anything else?
Doesn't look like it, right? Because now we're not translated or anything, right?
No. So that means that our other possible equation, and there are more, right? Depends where you start.
Right.
Is just x.
Voila.
So there you go. And again, feel free to throw this on the GDC to check that, you know, it does match.
Or Wolfram Alpha, right? They can use
Wolfram
that too.
Alpha, yeah, that's pretty cool too. And yeah.
That's it. Thanks.